for everyone as a reminder, but mainly for people who were here yesterday, we have 3 weeks left. You have, I haven't written it yet, but your deadline for all quizzes, whether you missed it, you're retaking, whatever. Everything left, except for the 2 that have expired, that have been up there forever, is going to be December 13th. You got a lot of quizzes due by then. Now, I'm not requiring tutoring because, again, mostly for those of you that were not here yesterday, but I recorded videos for the last, technically it was only 2 quizzes, but it's 3 quiz grades in the grade book. You're going to be able to just watch those videos on your own, review those videos, because I just did the quiz on the video. Like I just, same quiz you took, just did the quiz. And then I'll give you a different version when you come in. The quiz that's parallel lines, perpendicular, blah, 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 distance between a point and a line, that one won't really be any different other than the number. But if you could just watch the videos over and over and over again for that one, then the process will be the exact same on the retake. For the one that's rotations, reflections, translations, it was just 3 questions. That one will be a little different. I'm not going to give you the exact same reflection, the exact same rotation. I will probably give you the same type of vector problem. So as long as you know how to do that one, that should be an easy one. But just, if you study it, you practice the IXL, you should be good on that one. And then you have a brand new quiz on Friday, which is going to be based on these 2 concepts here at the bottom, as well as, I can't hang that up. As well as things like vertical angles, linear pair, which we'll talk about linear pair a little bit in that, not really vertical angles. But that'll be the new quiz. And then the back, so that'll probably be 4 questions. The back of that will be a free retake on the rotations, translations, reflections. So that'll be Friday. So prepare for that for Friday as well as preparing for this new stuff, and you can make a big impact on your grade on Friday without even having to come in to do any retakes. All right. So with that in mind, I'm going to give you a process. I'm not giving you a process, but I'm going to give you a very detailed process today on how to write rules. And then you're going to see questions that look virtually exactly like that, 5 of them on the exit ticket. And it's the same thing you'll do. There's something else I was going to say. I don't know. So here's the part where I hope you went through your notes and found stuff. If you needed it, you memorize it, that's fine. When we write a rule, we said there's 2 questions you ask. As long as you ask the correct 2 questions and you know how to handle them depending on what answer you give, you should be fine. What is the first question, Joseph? Well, the question. We said, when we're determining what the rule is, we said, looking at the numbers. So we're always looking at the numbers. Like, we're not doing anything here. We're looking at the numbers, and then that will tell us what to write for the rule. This is the rule down here. So again, the numbers, the 2, 3, -3, -2, really it's the pre-image point, and then the image point is really what it is. That's what the little A and the A prime mean. So what was the first question? That was probably before that. Yeah, that was. All right. So again, I'm adding to my list of calls. So you don't have it in there, you go to the top. I got a long list today. I really take notes. I thought I was surprised at that. But oh, Trinity, were you here yesterday? All right. What's the first question? Did they switch places? So again, if you don't have these, if you didn't find it, Or if you didn't look, you might want to just write it down. Some of you weren't here. So I look at these and and the numbers will always be like the same digit part. The 2 and the 3 will always be in there. Otherwise, you wouldn't have a rule. You go to a completely different number in the second point, well, there's no rule that you can follow for that. So we'll always have the 2 and the 3 somewhere. So I look at them and I say, okay, well, did that 2 and that 3, did they switch places when they went to the image? And what's the answer? Did, right? The 2 was in front, now it's in the back. The 3 was in the back, now it's in the front. So if your answer is yes, when you go to write the rule, you switch the order. If the numbers switch order, then the X and the Y switch order. If your answer is no, they didn't, like if the 2 was still up front, but it just changed signs or something, then I would have just written X and Y. If they didn't switch order in the numbers. So that one, most people did okay on that. Here's where most people messed up. So I'm giving you an additional process. I need to figure out now, second question, Elijah. It is not about positive or negative. Those of you that were not here yesterday. I don't ask, did it go to negative? I don't ask, did it go to positive? Or is it negative? Is it? I ask, did the sign change? That's all I care about. Positive and negative doesn't matter. And here's the part that I'm adding in that was new. You need to follow the number and match that up down here with the variable or the coordinate, part of the coordinate, or whatever you want to call it. So the 2 was the X and it moved to the back. I want to follow that X to the back. Because a lot of people put the negative on the wrong, they're not variables, but the wrong value. Like they put it on the Y when it should have been on the X, or they put it on the X when it should have been on the Y, or whatever it was. So now that I'm specifically looking at the 2, and I've created a line that mimics the 2 down there. Florian, did that change signs? It did, right? So if it's changed signs, follow your arrow. That's where you put the negative. That's where you change the sign from the one where the arrow tracks to the same spot. Again, most people that missed it got the Y and X in the right spot, but they put it on the Y instead of the X or whatever. Now I'd erase those 2 arrows. If you want to do a second arrow, if you think you can keep it straight, that's fine. I'm going to just erase it so I don't confuse myself. And I'm going to do the same thing now with the 3. So the 3 was here and it went to there. Well, that represents or is mimic or is the same thing as that Y going to there. And I asked myself the same question. Did that 3 change sign? That's for everybody. Got it down. Change signs, right? It was positive 3. It went to negative. So again, I don't care that it went to negative. That's not why I'm doing this. I asked, did it change signs? The answer is yes. That's when you put the negative. Again, nothing to do with positive and negative. Changing signs is the question. So that's how you do your rule. And hopefully it's obvious. If the answer was no, it didn't change signs, then I wouldn't do anything. I would just leave it as the variable with nothing in front of it. All right, so that's what you do. 5 questions, 4 out of 5 is 1 point, 5 out of 5 is 2 points. Make sure you remind me, I forgot in first period to even do it. So they're going to have to do it tomorrow. And I think you would all agree we do a lot better when we're doing it in the same class that we review it. So hopefully they look at it a little bit tonight. I'm going to set a timer just to make sure we get it done. 45, right? All right, so really quickly, so this is moving on to the somewhat new stuff. Those of you that weren't here yesterday, we might have done triangles before yesterday. I can't remember. What's the concept? Okay, you were here. Emiliano, were you here yesterday? What's the concept in the first one? Like how did you know how to solve? Like what's got to be true that allows you to solve for that X? What's the answer? You don't have the answer? here. What's true about what about 180? Oh, here's the concept, and then we'll convert that to an equation. The three interior angles, so interior means inside. Three interior angles of any triangle. Doesn't have to be anything special. Doesn't have to be a right triangle, an isosceles, equilateral, any triangle. That's what's called a scaling, meaning there's nothing really special about it. It's kind of weird looking. They have to add up to 180 degrees. Just as a way back review, how do I know those numbers in that X are about angles? You can just say that's out for the So what we said yesterday is the degree symbol tells you everything you need to know. The only thing we have in any shape, really, we're talking about triangles mainly now, but any polygon, meaning it has straight sides, all a polygon means, there's only sides and angles. There's really nothing else. Now you might have, it might look crazy, like it might be a really weird looking shape, still just sides and angles. Every shape. So if it has a degree symbol, then it's about the angle. And it doesn't matter how weird it looks. Like you guys have got to get over, oh my goodness, it's got variables and numbers and all kind of stuff in it. If I would have written that in an angle, then that's the measure of the angle. It has a degree symbol. If it has a degree symbol, it is the measure of the angle. We may not know what number this is. Like I have no idea what that is. But that is the measure of the angle. Hopefully we can solve for the variable and then figure out the measure of the angle. That's the goal. But regardless, that would be the measure of the angle if it had a degree symbol behind it. So you guys are pretty good when you just see numbers there, or maybe even when you just see an X. But then when all of a sudden there's like numbers and a variable in there, you kind of freak out like nothing changed. I mean, just there's more stuff. What if there's no degree symbol? What's it about? Eliana, you answer that one. What if there's no degree symbol? What would it be about? Yeah, we don't know. What did I say? There's only two things in shapes. Angles and what? What else? What else is in that shape, that triangle, besides the angles? What other parts of a triangle are there? There's the angles, but then there are the, friend.
The lines.
So what are the lines, though, when it comes to the shape? They're the sides. Sides. So if it doesn't, so again, there's only angles and sides. So if it has a degree symbol, it's about angles. If it doesn't have a degree symbol, it's about the sides, meaning it's the length of a side. Well, that would be added into a figure. Yeah, so we'll get to congruence marks actually in the next lesson. But congruence mark just tells us something about the side. It's not technically part of the image. It's telling us something about images. But yeah, you could have, that's the whole next lesson. After a bunch of congruence mark stuff. All right, so just really quickly, the way the equation would look, because I really want you guys to make sure you're trying to write equations. A lot of you are taking a shortcut and just saying, oh, well, I know if I add those two together and subtract from 180, I'll get the answer. But then all of a sudden, when there's variables in there, you can't do that. Like if that would have had 2x plus 20 and 4x subtract 10, you can't just add those together and subtract it from 180. You need to know how to write the equation. That worked when you were in middle school. That does not work when you're in high school. Write the equation. The three angles added together equals 180. Then you can solve anything as long as there's only one variable. What's the concept? Raul, can you tell me, this one's a little tricky, but number 3, what's the concept in number 3? To learn. Perfect. So we learned a couple things about exterior angles. I'm not really going to do anything about the one that said the 3 exterior angles add up to 360. Because that's in a later lesson where we do just all polygons. Turns out that for every polygon, the exterior angles all add up to 360. It doesn't have to be a triangle. So we're just going to push that back to that. This particular one means one exterior angle. For any individual exterior angle, it is equal to the two angles that in the book they call them remote. I normally say opposite. If you need to write all the way on the other side and write all whatever you need to write to understand, we don't use this one right here, which we don't know anyway. We use those other two all the way across. If that needs to be in your own word. They want us to write stuff up so you can copy down, which I will do on the next screen. But then you don't know what it means to do it back to it. So you need to put in your own words. Y equals, so here's the equation. This helps you to figure out what to write. Y equals 100 plus 48, the measure of y. Look guilty. Again, whatever you need to write to describe what you would call those two angles. No words. So I'm going to ask a super, super smart question or person this question. Oh, man, people I really want to work, I ask them, they're not here. Super, super smart. People. Eli. I know you guys remember everything I say. Never forget anything I say. You're always paying attention to remember everything I say. But what if you forgot that rule that I just gave you? That y is equal to 100 plus 48. What else could you have done to solve that problem? Well, that's the problem I want to solve for y. Well, I'm glad I'm recording because I didn't say this next thing in any class. I'm glad I'm recording this class because I say it. I used to say it all the time. What if it looked like this? What could you do? Look at the first problem. Or actually, technically, the second one, but the first triangle. Yeah. So here's what I'm going to tell you in this class that I did not tell the other classes. Don't worry about what you're trying to figure out. Do whatever you can. Do whatever you can. And write it for the thing. Do whatever you can. Whatever you can. Big fireworks going off. You guys get so caught up on trying to jump to the end. Oh, how do I solve that? And then you can't. But sometimes you can't. There's no way sometimes to go straight in high school. There's no way to go straight to what they're telling you to solve. Sometimes you have to do other things first. Like there would be nobody would be able to do it. Everybody has steps they have to do to get to that final thing. If you just figure out what you can figure out based on, whatever you know. A lot of times, all of a sudden, it's like a puzzle. You'll start to say, oh, wait a minute. Yeah, now I can do this. Oh, wait, now I can do this. And next thing you know, you've solved the whole thing. So do whatever you can. So if you didn't hear what Eli just said, if I kind of ignore that y, this is the same exact problem as we just did over here. I have one missing angle. I know two of the three angles. I could say this, and I'll put a question mark there. I could use an x, a different variable, and make it x if I wanted to. That angle is equal to 100 plus 48, and then subtract that from 180. Same thing we did in number 2. So question mark plus 48 plus 100 equals 180. So if I add those together, subtract them from 180, I get 32. Well, I could do what I know. I know that's true. The three interior angles have to add up to 180. Okay, wait a minute though. Now going way back to when we first started angles. Hang, what can I do now? Oh wait, Tiffany, what can I do now? Look what I just did. I just solved for 32. I want y. What can I do to solve for y now? If I had forgotten that other rule that y equals 100 plus 48. So again, this is, we're pretending like we forgot that. That's why I'm doing all of this. Just to show you there's oftentimes more than one way to solve the problem. What does it mean when I do this? Somebody knows. Somebody's excited. What's that mean? What does that mean when I do that? You better know what it means when I do that. Oh, I gotta make one copy of you. I'm gonna show you one more time. You're still gonna get called. Just because I keep saying it. It's this lesson. Ooh. I have a line. How many degrees in that line? No, how many degrees? How many degrees is a straight line? 180, right? So when I split it into two angles, what's got to be true about those two angles? Did I change the line? So it's still 180. So what's got to be true about that angle plus that angle? 80. They add up to 180. So this is a straight line. That plus that has to be equal. Got to know that. That's like when we first started. All right. So if I subtract the 32 from 180, I would get the same thing, 148. So again, a lot of times you don't need to remember that rule to still solve for the external angle. Sometimes there are problems where that's the only way that you have to do that. But again, do what you know. That's the moral of that story there. All right. Any questions on any of that? That's your Friday quiz. Like those three concepts, three interior angles, one exterior angle, linear pair is also on there. So this is the linear pair thing. And vertical angles. Don't forget we did some stuff with vertical angles yesterday, I think at the end of class, barely. You need to remember the vertical angles thing too. That was the first thing we did. Linear pair was second. And I told you they'd be the first two things you forgot. Most of you forgot. Take your ear pods out, please. Earbuds, headphones. I shouldn't have to tell you that every day. I just saw Mr. Gates walking around the hallway, which sometimes he stops in. So if you got earbuds, earphones, AirPods, whatever you call them, that's where we're eventually going. Like you're going to see one question on the quiz. You're going to look at, and it's going to be way more confusing than anything you've seen. You can still get a B without knowing how to do it, but if you want an A, you need to be able to figure out something that's way more complex. And it's not even that bad. I'm not going to go over it, but there are problems in the book like that. I don't know that there's anything that's really in IXL that's that difficult, but just know if you want to do well on it, you need to take your book home and look at some of those before Friday. Same thing there. That is not so much that the concepts are that much more difficult, but the algebra is more difficult on that. But there will be one that's tougher on that quiz. All right. Here's the new lesson. This is your topic. So this is, I think we're in 5-3 now. I'm not even gonna really be getting to the book. We're gonna do the lesson just for my stuff, and then you'll practice how it sells. So we won't use the book. I might assign some problems from the book, but mostly it'll be IXLs and my lesson. That I'm going to assign. Oh no, they were actually examples. I don't think they were problems in the book. So, I mean, I've got it recorded. If you want to go back and look, so take the book and match it up. But again, that's the expectation is the other stuff we've done. So I'll just, since you asked and since I'm recording, I'll show. This is the expectation for everybody. No reason why. What? This one? Oh yeah, that we did yesterday. If you weren't here, that's my expectation for everybody. You get all of those angles right. There's another section that's about like we said congruent parts of congruent triangles, like we're talking about you have to use the names to match things up. That I expect you to be able to do. The two that I just showed you, they're going to be much more difficult. But yeah, if you want to look them up, just watch the video. If we have time tomorrow, I can look them up too before Friday. Just remind me, or I'll try to do it maybe. But yeah, that I think everybody can handle. And the congruent parts, you just have to know really how to do the algebra and make sure you use the names. If you weren't here yesterday, you probably need to watch that part of the yesterday's video about where I get to the part where it said use the names and I like highlighted it on the screen. So copy this. I'll slide down in a minute so you can see the rest of it, but for now, just make sure you get all of the blue and the top triangle, and then I'll scroll down a little bit and you'll still be able to see the bottom triangle and the red and the green. Guess what? Shit. Somebody took my earphones. Do you know who I write? No. You haven't been taken. You might. That'd be so funny if somebody gives you a can, but then they like it and they took it for you. I definitely would know. Halo food. Yes. I'm not like it. He's gonna totally be giving it. He goes, are those up there for students? Like, why are those up there? And I go, oh, there's somebody that likes them. I've never ever said your name, so he really must know that you like them that much, and he took it for you. That's hilarious. That's too funny. You next time you see like, so do you have anything for me? See what he says, and then you'll know if he grabbed it for you or not. All right, so I'm gonna scroll down a little bit. Hopefully, you've gotten at least that top part written. There's not much more to write. That's it. Those are the IXO. LER, that's why it's kind of italicized, meaning it's slanted. That's the more important one out of those two. Looks like the majority of people are done, so I'm going to kind of start talking about it. So our lesson now is we're going to be proving that two triangles are congruent. That's what it says up top. Now, it's not always going to be as easy as far as the images go as that. There could be all kinds of images like this. Could be something like this. But somehow you're going to have to figure out whether or not the two triangles are congruent. And there's only four ways to do that. By proving that one of these four things is true. And when I say proving, we're not doing a proof. They're just going to give you markings in the image. And if those markings match up with one of these four things, then those triangles are congruent. And this is what you're going to practice a lot Thursday for you guys. And I'll finish our lesson also before that on Thursday, and then the whole second part of the block should just be all practice. And your exit ticket's going to come from IXL again on Thursday, where I'll walk around. I'll probably give you two questions, and you will get a point for each question you get correct. So we're only going to probably do the first one today since you have your exit ticket. And we're doing a little bit of review in the process. What does that mean? I don't really remember where I left off. Velocity, I never call it velocity. What's that mean? The red mark that I just put in there. What's that mean? We see that in an image. It means what? Oh, no, I told you to draw it. What's it mean, Trinity? It means they're congruent is what it's called, but really what that means when it comes to a shape is, yeah, that side is the same length as that side. So what congruence means in a shape just in general, it means that we talked about this briefly, but now you need to understand this because I've seen district questions that aren't about math. They're about understanding what congruence really means in shapes. It means we could take that triangle and we could flip it, rotate it, slide it, do all of those different transformations we've done. And eventually it would land exactly on top of that triangle there. So basically it means it's the same triangle. You can put one right on top of the other. So if they're the same triangle, that means for every side in this triangle and every angle in that triangle, there is a side that matches it down here and an angle that matches it. It's the same triangle. So they've got to have all the same length sides and all the same measure of angles. So the way that you prove it is that you're matching up sides and angles, and these four things, and only these four that I have in the red box, these four things, if we can match the sides and angles up and they fall into one of those four categories, that proves that they're congruent. If we match them up and they fall into one of these two categories over here, those do not prove they're congruent. That's not enough information on the right. I'm going to really quickly explain the bottom one. So imagine, well, actually, here I'll draw it like I did the inside. Plus, if I just explain it visually, there's. So if you can imagine a triangle, tiny triangle on your phone, and you zoom into that triangle, like meaning you make it look bigger. All that happens is it expands out. It gets bigger, but the angle doesn't actually change. This little tiny corner here would stay the same measure. You could measure it with a protractor. You're just making the sides extend longer. These two angles also would all stay the same. They'd be the same. So angle, 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 saying that all three angles in one triangle are congruent to the three angles of another triangle, that's not enough to prove that they're the same exact triangle. Like I'm showing here, I could have one little tiny triangle and one bigger triangle, and they have the same angles. So that's not enough to prove that they're congruent. The other one, SSA, is a little trickier. There's no real, I don't think there's a super intuitive way to explain that, but I am going to give you a little trick to help you remember it. So for this one right here, your memory trick, and that's all this is a trick, there is no profanity. A capital N, capital O. There's no, what's profanity mean? Or what? No bad words, no cuss words, right? There's no profanity, no cuss words in congruent triangles. So write that note down. And I'm going to wait for light bulbs to go off and you guys figure out where it's from. And there's one person at least. Sometimes it's like very obvious when somebody finally gets it. Ah. So if you're still not getting it, look at those letters backwards. If you're not paying attention at all, write it down now. There is no profanity or no cuss word. You don't have no profanity.
Okay, so if it's no,
Well, that means if you see a word that could be profanity, it doesn't prove congruence. That's what that means. So if we see a word that has letters that spell a bad word, especially if they were backwards from that, then they don't. You don't get it. What would that spell backwards? SSA would
They spelled that.
That's profanity. That doesn't prove congruence. So bad words don't prove congruence. So that's just a way to memorize it. There's nothing, that's nothing but a trick. This one you can kind of, I think, picture zooming in and out doesn't work. All right, so really quickly, we got to do this fast. We get to the exit ticket. So let's say I do that so that we know all three sides are congruent. That would mean that those are congruent triangles. That's what it says. I just need to prove. Oh, I did one wrong. So it says right here, if I have enough information to either show, like if I can figure it out, or if they just give it to me, which normally when it's two triangles, they're just going to be giving it to you. That is side, side, side. That proves that those are congruent triangles. But I'm just going to ask this to everybody for a time crunch. How can that be possible? Because if let's say I went clockwise to the next side. So from the one that has one congruence mark, I go clockwise, and the side clockwise, the next side I hit has three congruence marks. But here, when I go clockwise, that side has two congruence marks. How can those triangles be congruent? When if I clearly see I'm hitting a different side when I go clockwise. How is that possible? And I'm telling you, this is a rule. That is true. That means they're congruent. How's that possible? I mean, I could go counterclockwise and be the same thing. If I went counterclockwise, I'd hit two, but down here I'd hit three. Let's go hit a different side. No, it doesn't have anything to do with angles to draw my sides. It does have to do, hey, look at somebody. What did we just do where we did transformation? What was one of the transformations we did where it kind of changed the way it looked? Not a translation, not a rotation. That's your hints. What's the other one? Reflection, right? If I reflect that top triangle down, well, now the side with three is going to be down here. Two is going to go up there. Now, when I go or clockwise, I do hit the one side that has two. So that's why side doesn't matter. So here's what you need to write. So just take these last two things down and then we'll have to stop. When you are talking about congruent triangle, and really any image, you can say triangles. Now, left or right doesn't matter. Doesn't matter what's to the left, what's to the right, when we're talking about the sides and the angles. Left of this, right of that, none of that matters. And this is exclamation points, fireworks kind of stuff. But what does matter is between. If I put a congruence mark there and I want to show which angle matches up, I have to pick the one that is between the side with 1 and 3 marks. That does matter. So you can go ahead and fill it in on your own now. So if that is 1, and if I do 2 here, and then 3 here, you guys can fill that in where those should go. They got it. You got to put it between the correct sides, and I'll kind of fill it in for you so you can check it. So there. The one with 3 is between the 1 and the 2. The one with 3 up here is between the 1 and the 2. So between matters, left and right doesn't matter because we can always flip it over. And that would change the left and right. All right, so yeah, go ahead, pack up. Oh, I don't know if I have enough exit tickets. Oh, I did some. Oh no, they did fill it out. If I don't have enough, I'll just come back to some people, but we don't have a whole lot anywhere. I'll phone up. Yeah, no phones out. Like put it up. You don't take phone